All right, this is the Algebra 2 Unit 6 Lesson 8 video over compositions of functions. Compositions were covered at the beginning of the Algebra 2 course, and it kind of revisits them throughout. So this is meant as a kind of review with a little bit of an expansion using the types of functions that we dealt with in this unit. So we're going to talk briefly about kind of an overview of what a composition of functions is. So composition of functions refers to when we have two functions, and we're going to basically take one function and plug it into the other function. So first thing I'm going to do is talk about the notation. You'll see it written one of two main ways. There's one way right there, and the way we kind of read this is f of g of x. Another way is like this. In both cases, it's telling me to take the function g and plug it in for the x in the function f. So remember, we have two functions, and g of x. These are both telling me to do a composite where I take g and I take it and I put it in there for the x in the f function. So how does this look when we actually do it? So the way it looks is like if we had two functions, let's say f of x was 3x plus 5, and g of x was 2x minus 3. Okay? And so if we were asked to do f of g of x, I would be being told to take this entire thing and put it inside where the x goes in the f function. So the way that would look is I would do 3, and then where that x is, I'm going to drop the entire expression, 2x minus 3, plus 5. So notice I didn't change this portion. I just replaced the x with 2x minus 3. And then from there, it's just a matter of simplification. So I'm going to do distributive property here. 3 times 2x is 6x. 3 times 3 is 9. Plus 5 still there. 6x minus 9 plus 5 is going to give me minus 4. And so f of g of x is 6x minus 4. So again, you're just taking one function and plugging it into the other. Let's look at a few other examples. Let's say I was given the following. F of x equals x squared minus 2, and g of x is equal to x plus 4. So, and then they want us to find, again, f of g of x. Well, again, I'm going to take this entire function and plug it in for the x here. Notice I didn't include the squared, I didn't include the minus 2, just for the x. So this ends up looking, and the next step ends up looking like this. Parentheses, x plus 4 squared minus 2. And then I would need to continue working this out. This can be rewritten as x plus 4 times x plus 4. Again, minus 2. Then I have to do FOIL method. So I'm going to multiply everything like this. So I'm going to get x squared plus 4x plus 4x plus 16. You should know how to do FOIL. That's all I'm doing here, FOIL. First times first, outside, outside, inside, last. Minus 2. I'm just simplifying at this point. Then I get x squared plus 8x plus 14, because 16 plus 2 is 14. And so that would be f of g of x for that function. All right. I want to keep doing a few more examples to make sure I kind of cover all the different types that you're going to see in the lesson. And so you're super familiar. Let me just jump over to the lesson and see what we got here. So they've got some like the ones I've done. We got linear functions. They've got some that look like this, where you have exponents. Same thing down here. Same thing. These are all very similar. So let's talk about one where we have just single term exponential functions. So let's say I had 4x squared and 2x to the third. And then again, of course, they ask f of g of x. So again, we need to, just so you are clear, we're taking this entire thing and we're putting it here in for the x. So we'll rewrite it, and we'll start by writing 4 parentheses 2x to the third squared. So we got to work this all out. We're going to remind us of some of the rules about exponents that we should know. The first is that, well, first we're going to leave that 4 there. This 2 goes to each term. 2 squared, x to the third squared. So 2 squared, and then x to the third squared. Now, the thing you need to know is that when you do a number raised to a number, you multiply those two numbers. So it's going to be x to the 6th, because 2 times 3 is 6. So x to the 6th. Then we go to the next step, and I get 4 times 4x to the 6th. 4 times 4 is 16, x to the 6th, and that would be the final answer for this composition. That's very similar to what you're going to be doing in number 5 and number 6. Notice that here in one of them it's fg of x, so you're plugging g into f, and in another one you're plugging in f of x, so you're plugging the f into the g. So make sure you're paying attention to the notation and what that's telling you to do. Again, same thing in number 7 and 8, they want you to do both. They want you to do fg of x, gf of x. So you do both ways. All right, number 9, you're doing a function of itself. So let's talk about what that looks like. So that would be like you have a single function like x. Sorry, go back here. Go to 2x plus 5. And they say to do f of x. Now, in other words, they want you to take this and put it in itself. So it's like you're taking the thing and putting it inside the x of itself. It's a little bit weird. But think of it this way. Let's imagine we had 2, and then we put a blank for the x. And inside the blank, we put the original function again. So it's like we're stacking it inside of itself. And so we distribute 4x plus 10 plus 5. 4x plus 15 would be f of x. And then they have you stack it even further. So you can see they have you do it 3 times. Put it inside of itself, inside of itself. So you just need to, again, draw parentheses and put the function inside the function. So that's number 10. That's number 11. And then we get to the review questions. So I'm going to talk through these, and I'll put some things in the notes to kind of help you along. But just to remind you, for multiplying complex numbers, let's go ahead and go over here and open a new tab or a new drawing. When you do complex numbers, you do FOIL. So you do first, outside, inside, last. You need to do that for sure. And treat the i's the way you would an x. And then at the end, anywhere you have I squared, you need to replace it with a -1. That's the key. Okay, so let me show you an example. Let's say we have 2 plus 7i times 3 minus I. Let's see if that's similar enough to what you have. Yeah, that'll work. So again, I'm going to do FOIL method. FOIL method means I'm going to do first times first, which is 6. Outside times outside, right? I'm doing FOIL. That's minus 2i. Inside times inside, plus 21i. Last, 7. Okay, that's going to be negative 7i squared. I squared automatically needs to be replaced with a -1. So let's rewrite it. 6 minus 2i plus 21i minus 7 times -1. Keep simplifying. 6 minus, minus 21. Minus 2 plus 21 is going to be minus 19i. And then -7 times -1 is plus 7. So then my last should be 6 plus 7. So the 19i is going to stay. 6 plus 7 is 13. So I should have 13 minus 19i. So I'll put a little guide in the notes, and I'll leave that there for you. But that's what you're doing in number 12. Number 13, identify the conic section. There was something in the previous notes about doing this, so I will copy that into the notes for this lesson. But let's just jump back and see. I think it was in lesson 4 right here. So this is how you determine the different forms. I think there might have been another notes page as well. Anyways, I will find that and I will post that for you in notes for you to determine the type of conic section. Find the solutions to this linear system. Not much to say about this, but go graph it on Desmos and find the place where the lines intersect. So the solution is the place where they intersect. And that should be enough for lesson 8.